Hello again. In our previous lecture, we introduced the notion of certificate and what one might look like or how we might construct one. Today we'll talk a little bit more about that. Okay, so what was the problem that we were trying to solve? Well, in a distributed environment where you're dealing with parties that you don't know personally, we need to establish somehow a web of trust. And what that amounts to typically in one of these distributed environments is knowing that the identity and the public key of a party with whom you're dealing are actually legitimately bound together. And certificates are the way of doing that. Okay, so one way that we might accomplish that is by having some trusted third party vouch for this binding. And the idea there is that they produce a certificate which says that they're willing to vouch for that binding. Okay, but now suppose that Y has a certificate signed by X, and now Y wants to produce a certificate for W, which is his subordinate perhaps. Well, what one might do then is attach the certificate that X gave to Y to this new certificate, and then you establish a chain of these things, right? So W is vouched for by Y, who's vouched for by X. And you can have a chain of an arbitrary length, but it should be the case that this chain of certifications is grounded somewhere in some hopefully unimpeachable authority that everybody's going to believe. Okay, so this authority might gain their might gain your trust by the position that they hold, not necessarily by the fact that you know them personally. So for example, in the larger world, a notary public, for example, has this position of trust, and if you want to get a document notarized, you go to them, and it's not that they know you personally, but it's that they're trusted to check your credentials. And on the internet, a similar thing happens. So there are companies which are called root certification authorities which do this sort of thing. So VeriSign is an example of such a company. Well, you don't know VeriSign, so why should you trust them? Well, the reason is because it's their business to do these certifications. And so if they become untrustworthy within the marketplace, they're going to go out of business. And so they have a strong commercial incentive, a financial incentive, to guarantee that they get it right. And therefore, if you see a certificate signed by VeriSign, you can be pretty sure that they checked pretty carefully to make sure that the binding between the public key and the identity was in fact valid. Okay, so in the real world, we saw in our previous lecture, by the way, an example of how certification might work. And that's actually the way it happens in the real world with a little bit more detail. So there's a standard called the X.509 standard for digital certificates, and it's very widely used. And they have a lot more fields, but basically they accomplish what we discussed in our previous lecture. So for example, here's the fields, some of the fields in a version 3 509 certificate. You have the version number, a serial number, the signature algorithm identifier, which just says what signature algorithm you're going to be using within this context. The issuer's distinguished name, so that's the person that's vouching for the other party. The validity interval, that's important. How long does this certificate, how long is it valid for, right? And so if you get one of these certificates and it's expired, then there's no reason why you should trust it. The subject's distinguished name, that's the party being vouched for. In our previous example, that was Y. And then the subject's public key information, that's K sub Y in our previous example. And then a few more fields, the issuer's unique ID, the subject's unique ID, some extensions, and then finally the signature. That's really the important part. You take all those previous 10 fields, hash them all together, and then sign that with the issuer's private key. Okay, so then how does a person seeing one of these certificates validate it? Well, they obtain the issuer's public key, the appropriate key for this algorithm type, and they get that from field number 3. They verify the signature, which is on that hash of stuff that it was in field number 11. They recompute the hash from all the previous 10 fields and compare it to the received value, and if the two are the same, then they're pretty sure it's correct. And then finally they check the validity interval, because once again, if this certificate was for a certain interval and we're outside that interval, there's no reason to believe it. Okay, so what have we said? We said that these certificates can be combined into a chain of trust, but hopefully they're rooted at some unimpeachable authority. And that may be like the president of a company, but it also may be one of these root certification authorities like VeriSign. X.509 is a widely used international standard for these certificates, and you see these very frequently on the internet, and they accomplish this really great goal of establishing this web of trust. Thanks.